Okay, we are ready for the notes for 3B for the Math 4 course. I want to say that I wasn't quite this bad when I was a child, but I probably came close. I remember handing my mother a list for Christmas out of the Sears catalog and realizing I was going to get half the stuff, but at least it gave her a shopping list to work with. All right, we are going to take logarithmic expressions, and we're either going to expand them or we're going to condense them. And there are places as we get further and further into solving logarithmic equations, there's a place for each of these. Sometimes you can expand something so you can kind of get x by itself, and sometimes you can condense something so that you don't have quite so many players involved in a problem. So we're going to look at some examples of that. First of all, we're going to look at the rules. There are three basic rules here. First of all, if I have a log with a base and I'm multiplying the two guys on the inside, I can separate them with addition, like that. And for the quotient rule, it's kind of the same. Here we're multiplying, there we're dividing. It's going to be the same idea. It's going to be log base b of x minus log base b of y. Pretty simple. And you think about it, exponential rules, you know, if I had a to the x times a to the y, I would be adding those exponents. And likewise, if I had a to the x over a to the y, I would be subtracting them. So this should not be terribly surprising. Remember that logarithms and exponentials are inverses of each other. They have a relationship. Now, this last guy is going to do something curious. That exponent on the end can be moved out front. Sometimes that is helpful. And to be honest with you, in most cases, it's actually helpful to undo it and put the c back over the x where it supposedly belongs. But you know, you can go back and forth, whatever the needs of the problem. All right. Example 2, let's play with some of these. Now, first of all, I'm going to deal with the multiplication first. That's going to tell me log of 3 plus log of 2 to the third. And then that exponent is going to move out front like that, 3 times log 2. Like I said, sometimes when you got x all mixed up in all sorts of junk inside of your logarithm, sometimes this is a way to separate out the x. Okay. All right, now we got a division problem, which means that we are going to say log of 2 to the fourth minus log of 5. And then we are going to put the 4 in front. And that's as far as we need to take it. Here, we probably want to rewrite this. Instead of as a radical, we want to write it with a fraction as an exponent, a rational exponent. And so we're going to write it something like this. Remember, whatever is in the pocket goes underneath the fraction here. It's on the bottom of the fraction. And if there was numbers on the inside, they go on the top, something like that. Anyway, so if we got a fraction there for an exponent, we can move him out front. And if all of these are being multiplied, then I can separate them with addition. That should do the trick. Now this one, we're going the other way. Instead of expanding it out, we're condensing it down. That means that we're going to want to take the 2 and put it as an exponent over the 12, which means that you've got this, which means that you've got this. Now this one's a little uglier. This one actually, you have the 6s that you need to deal with. You have the plus that you need to deal with. And there's not really any rule that says which one should come first. I'm going to factor the 6 outside. Which means that I ought to be able to multiply them. Well, I guess I really don't need that outside parenthesis anymore, do I? Now, at this point, I can move that like that, and I can even do this to it. Now this one, there's a trick to this one that may not occur to you right away. The thing that they're hoping is that you will try and reduce the 6 over the 3, not realizing that the 6 is a log 6 and the 3 has no log to it. They are not like terms. You cannot reduce 6 over 3. That is a huge mistake. What we can do and say, if this thing is being divided by 3, I can think of it in these terms. 1/3 times log 6. Oh. Which means I can do this. Which means I can also do this. I actually would accept it at either level unless they specifically told you leave it with rational exponents or leave it as radical. Either way is acceptable unless they're specific. Now here, there is a little trick to this that I want to show you. Because first of all, if you're trying to evaluate and reduce this down to some number and you're really having a problem jump starting the problem, then I would suggest that you do this. Set it equal to x. Now you've got an equation that you can use some of your laws and properties about. For starters, if that 3 can go there, and that x can go there, and this whole guy can go down there. Oh, 3 to the x equals 3 to the 7. I know what x is. Now I want you to notice something. That if I were to come over here and say log base 5 of 5 to the 9th, my final answer would be 9. You see the pattern going on here. What's happening here is that by the time that I rewrite this, it's like log base 5 of 5 to the something. It's like all of this cancels out. And all I'm left with is the 9. That happens on a regular basis, all right? If I say log base 12, 12 to the 3rd. The log base 12 and 12 is going to cancel out. All I'm going to be left with is 3. So that's a thing. We've actually demonstrated that on the left, why it happens time and again. So we can do that on a regular basis. The more that we spot that when it happens, that actually, saves us some time. Now, here's a guy that if we say log 4 plus log 5 to the 2nd, well, that's actually 25. And since these logs are being added, 4 times 25 is 100. Now remember, that is actually base 10. If I don't have a base there, you assume that it's 10. And if I do this, then that means that 10 to the x is equal to 100. Guess what x is? Now, I want to show you, when they work out nicely, where you can recognize the numbers like that, that's fine and dandy. But occasionally, you are going to come across a problem where it's going to look like this, or you're going to have like log 4, log base 4 of 7. And we have this little trick that we call the change of base. Where we can take, it's like the base is down lower than the 7 is. And so we can rewrite it like this. Log of 7 over log of 4. Now, you can punch that in the calculator. Although I'll warn you, if you say log of 7 divide log 4, you better have both parentheses around that guy. Order of operations is going to screw you up otherwise. So I'd go ahead and get in the habit of putting your parentheses around both ends of that. When you punch the log button, they will start you out with the left side, but you got to close out the right side, because up here, if you don't with the 7, order of operations is going to mess up your answer. So, but this allows most calculators, unless you've got one of the high dollar, latest model TI-89 kind of thing, then they will give you a place to put in a base for a log to calculate, what is log base 4 of 7. But most of your older models, TI-83, 84s, they don't have that feature, and so you have to do the change of base to be able to plug it into the calculator. All right, so I'm giving you that now, just knowing that we are probably going to trip over this, especially in the worksheet coming up after this. All right, so here I'm going to remind you of one of the properties of exponents. You put the x to the a on the top, and you put the x to the b on the bottom. All right, that's what happens there. So we're going to rewrite this in the same fashion. Now, remember up here when we said that the log base 3 of 3 cancels everything out and just leaves us with a 7? The same kind of thing actually happens when you have a 5 base that is raised to the exponent of log base 5. They have a tendency of canceling each other out. Now, I know you need to see this to believe that Mr. G is not just blowing smoke in unpleasant places. So here we go. We're going to set it equal to x. And if we are doing that, then we should be able to say that, not that. We should be able to rewrite it as log 5 x. Now, that doesn't look that clean. All right, if we rewrite this into logarithmic form rather than exponential form, even though it's got a log inside of it, this is still basically exponential form. You got the base, you got the exponent, you got this over here. All right, now if log base 5 of x equals log base 5 of 10, guess what x is? Remember what I said about these guys also canceling out? That means that you're just going to have 10 over 5, which is plain old 2. So, not only are you going to see these guys canceling out in this order, but you're also going to see it in this order over here, the log base 3 of 3 to the 7. These are both cases where the log and the base actually kind of cancel each other out. All right, we got 2 more to go. This one should be pretty easy. If I'm adding them, that means that I'm basically multiplying them inside, which means 21 instead of 7 times 3. And bada boom, bada bing. Now this guy, we needed a couple of steps. First of all, we're going to move the 1/2 back over here. Then we're going to say, well, what is something raised to the 1/2 power? It is the square root of that number. And what is the square root of 36? That's 6. And when I am subtracting like this, especially when the bases are the same, I can do division, which means I can simplify that to that. And that is the end of our notes for section 3B.